Hello everyone. I welcome you all in this video tutorial on Introduction to Data Analysis with Python. I'm Madhuri Jha, DevOps Specialist at Thinknyx Technologies, and I'm here to present this tutorial on data analysis with Python. Data analysis is a critical skill in today's data-driven world, and Python has emerged as one of the most popular languages for performing data analysis tasks. Whether you are a data scientist, a researcher, or a student interested in making sense from data, this tutorial will provide you with the foundational knowledge you need to get started. In this video tutorial, we are going to explore what data analysis is, understand its importance in brief, discuss the different Python libraries for data analysis, get an overview of Pandas library, learn how this library helps in analyzing data in Python, and towards the end, perform a hands-on demo on the same. So let's begin. Let's begin by understanding what data analysis is. In simple terms, data analysis is the process of collecting, examining, cleaning, transforming, and modeling data with the aim of discovering useful information, drawing conclusions, and supporting decision making. It's a crucial step in turning data into actionable insights. Data analysis is a critical process in the modern world, transforming raw data into valuable insights that drive decision making across various fields. Let us explore few significant reasons why data analysis is important. Data analysis provides a strong foundation for making informed decisions. By examining data, businesses and organizations can identify trends, patterns, and relationships that would otherwise be hard to find. Predictive analysis involves using historical data to forecast future outcomes. By applying statistical algorithms and machine learning techniques to historical data, organization can predict trends, behaviors, and events that are likely to occur. This capability enables proactive decision making and strategic planning, allowing business to anticipate market changes, customer preferences. Analyzing data helps in identifying potential risks and areas for improvement, allowing for proactive measures to be taken. When it comes to efficiency and productivity, data analysis helps in optimizing process and workflows, identifying bottlenecks and areas of inefficiency. By understanding data, organizations can allocate resources more effectively. Analyzing market data allows businesses to understand customer needs and preferences better, enabling them to tailor products and services accordingly. Data-driven insights inform strategic planning, helping business stay ahead of the competition. Data analysis is essential for identifying the root causes of problems, which is crucial for problem solving. By regularly analyzing data, organizations can engage its continuous improvement, refining their processes and products over time. Data analysis enables business to personalize their offerings to individual customers, enhancing their customer experience. Analyzing customer feedback and behavior data helps in understanding customer satisfaction in areas of improvement. It plays a vital role in research and development, helping to validate hypotheses and drive innovation. Data-driven approaches ensure that practices are based on evidence rather than assumptions, leading to more effective outcomes. Python provides an extensive array of libraries that facilitate efficient and effective data analysis. Some of the most popular libraries include Pandas, NumPy, Matplotlib, Seaborn, and SciPy. Each of these libraries serve a unique purpose. NumPy provides the fundamental data structures and mathematical functions for working with multidimensional arrays and matrices. Pandas offers data structures and operations for manipulating numerical tables and time series. Matplotlib is a plotting library for creating static, animated, and graph interactive visualizations in Python. Seaborn is based on Matplotlib and provides a high-level interface for drawing attractive and informative statistical graphics. SciPy is a library used for scientific and technical computing, containing modules for optimization, linear algebra, integration, and more. Our focus is Pandas, which is at the heart of data analysis in Python. Its name originates from panel data. Pandas is known for its powerful data structures, the data frame, and series, which allow for intuitive manipulation of data. With Pandas, we can easily perform tasks such as data cleaning and transformation, handling missing data, data filtering, grouping and aggregation, merging and joining of datasets, time series analysis. We will be discussing each in detail in our upcoming videos. To begin with, a data frame is a two-dimensional labeled data structure with columns of different types. Here's a simple code in straightforward steps. Import the Pandas library, initialize Python dictionary, convert to data frame, store it in a variable df, then print the data frame, and the result is the tabular data in console. Now let's put our knowledge into practice with a small demo. Welcome to the demo section on data analysis using Python and Pandas library. In this section, we will walk through a simple demonstration of how to analyze data with Pandas. Before we get started, let's cover a few prerequisites. You should have a basic understanding of Python and ensure that Python is installed on your system. If you haven't installed Python yet, please do so. Python is already installed on my system. To work with Pandas, you need to import the library. If you encounter a module not found error, you can install Pandas using pip install pandas, or you can also install Anaconda or Spider, which are scientific environments where Pandas is pre-installed. Let's start by importing the Pandas library. We will use the alias PD to make referencing it easier throughout our code. If you don't see any errors, it means Pandas is installed correctly. If you do get an error, make sure to install Pandas as mentioned earlier. For this demonstration, we will use a small dataset to make things simpler. We will start by defining our data in the form of a dictionary. This dictionary will have 3 keys: name, age, and city, with each key having a list of values corresponding to 6 people. Here's how we can define the data. Next, we will convert this dictionary into a Pandas data frame. We will initialize a variable named df and use the pd.dataframe function, passing our dictionary data as an argument. Then print df displays the data frame in tabular format in rows and columns. Now that we have our data frame df, let's look at it to see what our data looks like. To get a quick look at the first few rows of our data frame, use the head method. By default, it will display the first 5 rows. This method is useful for getting a sense of what your data looks like without overwhelming yourself with the entire data set. If you want to view just the first row, you can specify the number of rows to display in parentheses. This will show only the first row of the data frame. This is particularly useful when you have a large dataset and want to check a small sample. To get some basic statistics on our numerical data, use the .describe method. This will give you a summary of statistics like the mean, standard deviation, minimum, and maximum of the age column. Now let's proceed and save the data frame to a CSV file. To create a CSV file data2.csv that corresponds to the data frame in the code, you can use the to_csv method provided by Pandas. We save the data frame df to a CSV file named data2.csv. The index equal to false parameter ensures that the row index is not included in the CSV file. This CSV file can be opened with any text editor or spreadsheet software, and it represents the data in a tabular format, just like the data frame. Now that we have saved our data frame to a CSV file, let's add a new row to it and then saving it again. Now let's read the updated CSV file and display it as a data frame. Read_CSV method is used to read a CSV file and then display as data frame. Print df to display the data frame. You should now see the new row added to the data frame. As we got an understanding of writing to and reading from CSV file, let's filter out some useful data from it. If you want to filter the data frame based on a condition such as finding people older than 30, you can do so by accessing the age column and using a Boolean condition on create a new filtered data frame. Similarly, if you wish to filter the data frame for finding people younger than 30, just change the greater than sign to a lesser than sign and see the result. Next, let's explore the concept of grouping and aggregation. Suppose we want to calculate the average age based on the city people belong to. We can do this by grouping the data frame by the city column and then applying the mean function to the age column. So let's modify our CSV file to get clarity of this topic. Consider few people belong to common city and then save the file. Suppose we need to calculate the mean or average age based on grouping city. The group by method creates groups based on unique values in the city column, and the mean function calculates the average age of each group. The result is a Pandas series, one-dimensional labeled array capable of holding data of various types, where the index is the unique city names and the values are the average age for each city. These operations are fundamental in data analysis and are often used to explore and summarize data, derive insights, and prepare data for further analysis. That concludes this demo. And there you have it. We have covered importance of data analysis, basics of data analysis in Python, introduced you to Pandas, and shown you how to perform some common data analysis tasks. Remember, this is just the beginning with Python and its powerful libraries. The possibilities are endless. Thank you for joining me in this tutorial. Happy coding and happy analyzing.